All right. So, um, over the holiday break, I added some tests. So at the end of the last meeting, we uh, set up the PyTest framework and wrote a few simple tests for some of our database interface functions. And so, as a part of that, I continued that work and added a few more tests and fleshed out some of the functions in the interface to have it be more in line with um, what our eventual user interface is going to do and the kind of interact and so it can support the kind of interactions that we want. So um, and I was also able to verify that um, all of the functions that I've written so far work. So as I was writing these tests, I came to realize that there were certain things that our interface needed to do that we hadn't explicitly declared in our design document. For instance, when you add a feed, if it specifies a group that does not exist, do you create the group or is that an error? And I opted to create the group. Similar. Also, if you update a feed, like change its parameters, like change its um, uh, change its name or any of its settings. If you change its group name, then what should you do then? And so I opted to have it add groups if the group does not exist. And so I implemented that and I wrote the tests to verify that yes, the group is created and that the new feed is points to that group automatically. But when I was looking over at this morning in preparation for this meeting, it dawned on me that like, okay, so what happens if we update a feed and um, and the group no longer exists or it no longer has any children? I was like, do we delete the group? And I think the answer to that question is no, because we can also add groups. We also have a method to just add groups um, willy nilly. So willy nilly, that makes me sound old. Um, Add groups and have an empty group there that's just available. Now our interface is going to have when we create a feed or when we add a feed or update it, one of the things that I hope to do is under the group, you can either select from a list of existing groups or you can enter in a new group. And so we want the ability to add a group and have it be empty. That's perfectly acceptable. So I think that the appropriate thing to do in this case is if we update a feed and switch it to either no group or a new group, is that we don't do anything to the old group. Um, so I think that the way I've got it written now, which already does that, is the way that we're going to leave it. Now, if we get to the interface design phase and we look back at this and we realize, oh, that's not going to work, um, we can always implement the automatic removal of empty groups um, based on situationally from the controller side. So the interface already has the tools we need to implement that if we wanted to, and then do it conditionally. So it's not necessary that our DB interface does that for us automatically. We can make it do it automatically. We could put a command line option in there to do it, but that's not actually necessary because we can always grab the group that the feed used to belong to, and if it's empty, we could do something like pop up a little message that says this group is now empty. Do you want to delete it? And then yes or no. And that that's probably the simplest thing to do. So one of the things that I've implemented here in um, is if you set up a feed with a group, you should be able to delete that group. And this is a feature of our ORM. If we delete the group, then the feed will drop its reference to the group automatically, um, so that we don't need to um, do anything about the feed um, the feed state changing. And so, from our interface side, what we would want to do is query for the feed again, or get the updated feed dictionary via our database interface, and that will change the group membership automatically for us. And so this is one of those things where when we delete a group, we don't necessarily want to delete the feeds associated with the group. And so what we'll do is we'll transition them to a state of not having a group, which should happen automatically, but we need to test it. So what we're going to do is we're going to take our test add group via feed as our starting point, and we'll just stick it down here at the end. And then we're going to grab the guts of test delete feed. Okay. And so we're going to, let's see. So we are going to, we're not going to add a feed. We are going to get feeds. Let's see. Feed ID F. Okay. So let's see. So this is going to automatically create our group. And we just need to, we don't necessarily need to look at the feed because we've already tested this elsewhere. And then what we're going to do, so we're not going to add the feed. We are going, let's see, we do need, let's see, feed ID, group ID. Okay, so we have our group ID. So then what we're going to do, we're not going to delete it. Let's see, we already have our group ID. We don't need our feed. Well, let's see. We need the feed ID, which we already have. And let's see, so we've got our group. So then we're going to take our let's see, delete feed. So we're not deleting the feed, we're deleting the group. Oh, I have not tested. Oh, so I was actually, that was not test feed, or that was not delete feed, delete group. That was, okay, test delete group with ID. This is actually what we need. So it's session delete group. Okay. Let's see. Oh, and I've actually misnamed. Let's see, there's the name lists. Okay, name list. Okay, so delete with name. Oh, I've actually flip-flopped these names. This is actually should be ID, and that should be name. Okay, so we're going to grab this guy right here, which is what we actually want to do. And let's see, so we're going to do this. So we're going to take our group ID. We're going to, oh, hey, Gotham. We are going to,
Hey, Kyle.
we're going to, we've created our group. Now we're going to delete our group. Now we're going to get our feed. So we're going to get our feeds, and now our dictionary should look like this, because this feed, which belonged to test group before we deleted the test uh, let's see. So this feed, which belonged to our test group, should now belong to none. So we're going to say, let's see. So we are going to do assert f ID equals our old feed equals our old feed ID. Okay. And then we should also assert that test group is not in our feed dictionary. Okay. So let's pull our tests over here. Collected 8 items. Oh, test group add via feed. Let's see, it's test. Let's see, test group delete feed remove. Let's see, feed. Let's see, feed no group. Okay. Now if we run this, all right, it works. So, so PonyORM is doing exactly what we expected it to do. It's when we create a feed. So it doesn't matter how the feed is created, but we get our feed and our group. We already know that our feed will belong to that group because we've verified that in another test. But once we delete the group, it no longer exists. And when we get all of our feeds, that same feed that once was in test group now does not belong to any group. So PonyRM is taking care of cleaning up that relationship, and so it's modifying the table. So when we delete the group, it goes into our feeds table and modifies all of the feeds that reference that group and changes them to none. So that when we get our feeds dictionary, when we get our feeds dictionary, now our old feed that was in test group is now in the none group. So that works the way we expect. All right. So now I think we are ready to start. We're ready to start creating our interface for. We're ready to start creating our interface for actually going out and querying feeds and actually building up this database. So we'll go ahead and use some. The only tricky part of this is that our tests are going to have to communicate with the internet in order to run. So if we look at our, let's see, so there's our client requirements. Where's our requirements.txt? Okay. So we have ASCII-MEDIX requests, gRequests, feed parser. Here we go. Okay. So we've got feed parser installed. Let's see, pip list. Yeah, right there, feed parser. So I'm going to pull up the feed parser documentation. And I will post a link to that in the chat so you can follow along. Python feed parser. And we are going to write our interface around feed parser. So the other thing is that we are going to use requests and therefore G-requests to actually get the contents of the feed. So feed parser. So that's actually an interesting um, question that we have to answer real quick. More chat. So here's the documentation for feed parser. I'll pull it up here for a second. So feed parser, let's see, it does not, let's see, it does actually can go out and get the URL for us. So we have feed parser, so we can point it at a URL and it will go out and it'll grab it for us. Now, we probably don't want to do that because we want this to be coroutine friendly. And so this is probably not using, so this is, we can do some monkey patching using gEvent in order to make this coroutine friendly, but it's still probably not the best way to do it. So what we're going to want to do is we're probably going to want to parse from a string, which is actually good because then we can do all the getting and the management of the feed data with G-requests on our own, and that way we can do things like so we can do all of our requests asynchronously using G-requests. We can stack up as many of them as we want, and then we only actually have to deal with them in we only have to deal with them when the request comes back. So that also makes it pretty easy to write our interface. It makes it easier for us to write our interface center tests, at least for dealing with the parser. So let's start with, let's see. So we have feed parser. So we should be able to just go Python and then import feed parser. Did I spell that right? Yes, I did. Okay. So we'll probably want to do feed parser as FP. Hopefully we don't confuse that with file pointer. But that kind of gives us our start to writing our interface. Okay. So in our source, we're going to create our feed. We're going to create a feed parsing interface. So let's go File, New, Python file, and we'll call this we'll call it feed parsing. Because that's all it's really doing is actually dealing with the parsing and getting data from our feed. Let's see. So okay, and we've got a new file. So we'll do from feed parser, or no, actually we'll do import feed parser at FP. And so now we need to define our interface for actually parsing feeds. So we've got our database interface. I probably need to update this because I've added some more functions. I'm trying to remember if I gave my lecture on design documents versus reality. So a common problem is that you can spend forever on your design document and it will never be a perfect reflection of what your actual code is going to look like unless you update it after the fact. And or you're updating it as you're actually writing the code. um, because there's always going to be things that you forget about. I mean, if your software engineer is looking at the design document that you gave him and he's not coming and asking you questions, he's probably, you've either written a perfect design document, which you haven't, or he's not doing his job, or he's just taking your design document on blind faith, which is not great either. So um, there's actually there's an article about this, an ex where the example he uses is coming up with a design document for a function that divides one number by another, and how it's impossible to get it right, or it's really difficult to get it right until you actually start writing the code, and then you're forced to deal with all the errors. Um, and looking at his original design document that he writes for it, it looks completely complete and rational, and it's not. And through code, he demonstrates why that is. And so that's just the reality of design documents. I'm not saying design documents aren't useful; they are very useful. It's just that you can't take them on blind faith. You got to be consciously engaged in what the design document is trying to do, and what it actually means when it comes to writing the code. So, yeah, what I've been known to say is if you can't trust a programmer to write your design document, you can't really trust him to write your program either. So, um, because writing the design document is easier than actually writing the code in practice. So let's come up with our feed parser interface. Feed parser interface. All right. So what do we want this thing to look like? So we're probably going to define a series of functions and or classes that are going to help us derive information from the feeds that we um, that we download. And so part of this is when we are querying. So one of the things that the feed parser interface does do for us when it goes out for the URL, one of the things it can do for us is um, it can put information into the request that will limit the results that you get back from the query. So one of the things that you can get back in an RSS feed when you query it is a timestamp or an identifier that's an indicator of the last time that the feed was modified. So you can, so then you can subsequently submit that information on subsequent requests, so you can get back an HTTP response that says there's no new information. So instead of getting back a 200, you get, I can't remember. It's not a 404, but it's something else. It might be in the 400s, or it's not an actual error condition, but it's basically there's no new data response. And so feed parser knows how to put that into the HTTP request. If we are only using feed parser to parse the actual results that we're getting back, we're going to have to figure out how to submit that ourselves. And that involves putting it in the header. Fortunately, requests makes that easy to do. It's just a matter of putting the right thing into the header so that we can have the server that's serving our feed tell us where to go if we are making requests more frequently than they're updating their data. So let's think about this interface here. So what does it need to do? So the first thing it needs to do is we need to have a parse. Obviously, we need to have a parse feed function. And it's going to take the feed data, which is just going to be a string. that contains all of the data that we got from the most recent grab of feed. And then let's see, does it need anything else? I don't think so. And then what do we want it to return? So we probably want it to return some sort of data structure. Now we can just have it return what feed parser returns. The question is do we want to submit any feeds back into it? Do we want this to only tell us about new feeds? Do we want it to tell us about do we want it to do some sort of pruning? And there's a couple of ways that we can do the pruning. We can specify we can specify a newer than and have that be a date time, and we would make it optional. Let's see, newer than, yeah, make it optional, and have it default to none. And so what we could do then is this, as we are, so what we could do then is we could iterate through our data structure and only return, have it like prune out all the feed items that are older than the newer than date. And if there is no newer than date, then we just leave them in. So what else? So what else does it need to return? So probably what we want to do is so we probably want it to return some sort of object. So let's look at what feed parser gives us out of the box. So let's see. So it gives us a dictionary back, and let's see, it's the feed itself, and then so it's basically a dictionary of dictionaries. Let's see, parsing from remote, parsing from string. Okay, so let's look at the basic features. Let's see, parsing feed from remote, from string, common RSS elements. Here we go. So this is going to give us a little bit of more information about the kind of things that we get back in the data object from feed parser. So we get the and we have a get attribute interface, and we also have a dictionary like interface. So we can do d feed. So feed is going to be general information about the feed, and then the title of the feed. So that's what we want. Let's see, we have the link for the feed, we have the feed description, the last published time, and the last parsed. Let's see, the published parsed is different from published, and I forget exactly what the distinction is. Okay, and so the important thing that we want is the entries. So the entries are the information about or is the information. It's basically a list of all of the entries that are currently being published in the feed. And so we have, oh, that's right, published and published parsed. So published is the actual string. Parsed is a time tuple, which can easily be turned into a datetime object. And so feed parser, apparently this is a standard format. This value here is the parsed. It takes the published string and parses it into something useful. Like I say, this is easily turned into a datetime object. I think you can call datetime from time tuple or something like this, that on this tuple, and it will turn it into an appropriate datetime object that we can use. And let's see. And then I'm not sure what the ID is for that. In fact, we'll probably want to look at what that ID is um, in the documentation for FeedReader later. Okay, so that these common elements are probably the only thing that we need. And so then the question becomes, do we want to do anything to the object that we get back from feed parser? So if we're going to implement newer than, we pretty much have to. And then the question becomes is, can we delete entries that are can we modify this object? And so then it becomes a matter of looking at how feed parser builds this data structure and what kind of modifications we can make to it before we hand it back. That's the simplest thing to do. But I feel like we might want to actually copy the contents of this out and get it into a more well-defined data structure, so that if we ever switch from something besides feed parser, or we end up writing our own parser, then we have a well-defined interface, common interface for our data structure that if we switch libraries, it's just a matter of shoehorning the data back into that data structure, and then everything else will just work. So let's describe that data structure really quick, and we're going to base this on our DB model, because we have the feed and we have the feed item. So the feed is that's our database entry that's for our entire feed, and it's created once the first time we access the feed. And then our feed item is for each entry in the feed. And so this basically becomes our list of things that we need to get from the resulting feed object. So we're just going to spell this out, and we can use something similar to what's defined in our we can use the same names as what feed parser is using, but it's not necessary. And so then then becomes the question is, do we want to create a class or a class object to hold this in? That's obviously what feed parser has done, because you've got different ways of accessing the same information. But we really don't need to create a dictionary-like interface. In fact, if we come back here to the introduction, we have this dictionary-like interface, and then we have the attribute access interface. We really don't need to supply both of those. As long as we have a well-defined interface for this whole thing, it should be pretty straightforward. And we can do it with, there's a couple of ways we can do it. We can do it with a tuple, like a named tuple, which would work pretty well. We can do it with and the name tuple would have like a title or a feed dictionary that basically has all of these elements in it, and then we have the feed item, and then we would have like the second thing of the tuple would be a list of entries, and each one would have a dictionary of all of this information in it, if it's available. Let's see. Last modified this. Why did I make this a string? I bet this should be a date time. Let's see. Text viewed. Read. Required time. timestamp. Yeah, okay. Um, I'm going to change that to a date time because I think that's more appropriate. I remember why. I remember why it's a string, because this is the thing that we are going to submit back to when we query the feed. The last modified, uh, um, yeah, or the e tag. You don't want to take a date time object because you have to turn this back into a string and it has to match their format. So it's just way easier to just take their last modified um, or feed. In this case, if we look here, it's the feed published. You just take this string verbatim and stick it in your database, and then you send that back to them, and then it's guaranteed to work. Whereas if you parse it and then try and recreate it, there's no guarantee that the server will look at this and say, well, this is, it might never match because they might just be doing a string comparison. And so since you want it to be exact based on what they gave you, you just want to store it as a string. Okay, let's remember. Let's see. Stored as a string to send right back to server request. Okay. All right. So now that we got that cleared up. So let's see. So I'm just going to set this up in the most general terms. So we'll do feed object. Let's see. There we go. Feed object. And it's going to have the feed. I'm not hungry. And the entries. And the feed is going to have okay. So let's see. We need the name. We need the URL. We need the home page. Let's see. Update and update rate have to do with our bookkeeping, so we know how often we've actually run our update. So those go away. E-tag, if available. Last modified. If available as string. Let's see, and then group and items we don't need. Okay. And then for our feed, or for our entries, we need, see, enclosure URL, enclosure URI. Okay. Let's see, the enclosure URL and URI, if available, the timestamp. See that one. Let's see, as date time. And then read and viewed is for our bookkeeping, so we can, like, say, show only unread. If we haven't actually viewed it yet, we can like put up a little asterisk and say you have unviewed feeds. Let's see. So the text is required, the URL is required, and need the composite index because that's part of our database definition. So this is the thing that we need to actually create the entry in the database. Let's see. Required indexing. Yeah. Okay, so those should default to false. All right. I think there might be a way that we can change these so we can create this feed item object without actually we can change this feed item object without actually or we can create one without actually specifying the read and the views. I think there's a way that we can say these are required and then set default values. In fact, let's look that up real quick. Let's see. Docs. Let's see. Required default. Required unique. Required and optional. Let's see. Okay, so we're going to have to look in the API reference for this. F required. Okay. Next. Entity definition, entity attributes required. Okay. Composite indexes. Okay, max string length. Decimal precision scale. Oh, that's kind of cool. Date time unique. Oh, here we are. Okay, so default allows you to specify the default value for the attribute. Default values in Python doesn't add SQL default clause. This is because the default expression is not only constant but an arbitrary time. For example, if you need, let's see. For example, blah, blah, blah. If you need to set a default value in the database, you should use. Okay. So, it can be a numeric, a string, or a function. All right. Let's see. So what we'll do then is, so what that means is since it can be a function, we can do this. Default equals bool, and just pass it the bool, the boolean type. So it will call that to create the default value. And if you call bool, it returns the default bool object, which is false. And since we want these to be false, we can just pass that in. I think we could also pass false like this, but this is more. I think this is more in line with what they want. So let's see. What did they say? Let's see. Nope. Okay, if you need, okay. I think if we set it to the false, if we actually set it to false, it would work because it would end up getting turned into a 0, or the string false, which I think works too. But I'm just going to go with that. Okay. Let's see. Is there anything else? Time Okay, so this actually, let's see, get feeds, update feeds. I noticed now that we don't actually have an interface in our database interface for setting up the adding and removing, or the adding of and the querying of feed items. So if we call um, get feeds, it gives us all the feed objects, but it doesn't actually give us the feed items. And we actually don't want it to give us the feed items. So this method is more for building up our menu of all of our feeds. But when we want to add feeds or um, query feeds, that requires a separate interface. So let's see. So we have get feeds, delete feeds, update feeds, get feed items, add feed items, update feed item, delete feed items. Okay. So these functions right here, see, good thing we wrote our design document, actually tell us some stuff that's missing from our database interface. So since we're almost out of time, these are actually, we should probably write these and their tests next. And I will probably do that on my own time because it just follows the pattern that we've got here. We're going to add the methods in, add some tests for them, and run it. And then we might change these um, uh, as we are looking through and trying to um, trying to figure out how we want this to work. Like for instance, looking at this, I realized that we're missing a method. Unviewed feed items. Um, and this is just going to return true or false. That's something that we need to do. So we have unviewed feed items, and then we need unviewed. Yeah, well, I don't care if that's spelled right. So that's going to tell us whether or not we have any, a feed is updated, but we've never actually looked at the feed item. We've never displayed it to the user. And then let's see, get feed items, unread group, feed none. Okay, so that's correct. Let's see. Actually, instead of returning a bool, let's see. We could make this a little bit more sophisticated. So the reason for this method is in your interface, you want to have some sort of indicator that new feeds have come in since the last time you looked at the application. You put like an asterisk or something somewhere, or you put some sort of indicator up so that you can tell that something new is happened. But we could make it a little bit more sophisticated than that, and actually have it return a dictionary of um, groups, or we could have it return a dictionary of feeds that um, I guess there's a couple of ways we could do this. So maybe we don't do this. Maybe we in our get feeds call, we add some extra information to this, where we say, does this feed have any unviewed or unread items? I'll have to think about that. So this is going to require some more thinking about how our interface works. So again, per usual, our design document is and always will be incomplete. So we'll have to put some thought into that and then go forward. So yeah, but we have accomplished a few things. We wrote a test. We have looked at our feed. We've started our feed parser interface. And so that will help us move forward as to how we want to design our functions for actually parsing our feeds. And so the next thing we're going to need to think about is what other parts of our interface do we need, if any. This might be sufficient right here. If all we're going to use feed parser for is actually taking the contents of what we retrieve from taking the contents of what we retrieve uh, uh, from an RSS feed and just passing them off to the feed parser and then getting back this data structure, that might be all we need. But we'll have to think about it and work through it as we go forward. So that's all I've got for today. Are there any questions? If not, we will call it a meeting.
Thanks, Kyle.
Thank you.